Hello algebra friends, this video is going to be a little mini lesson on how to add and subtract polynomials. So we've talked about polynomials before. They are just these really long expressions. So this would be an example of polynomials, and we'll define them a little bit more specifically in class. But for the warm-up, just go ahead and pause your video and just do the warm-up. Combine your like terms. This is something we know how to do. All right, so combining like terms, brushing off cobwebs, we're just going to put like things together. So I see 2x cubed and minus x cubed. So 2x cubed minus x cubed is going to be 1x cubed. Of course, we could just write that as x cubed. We don't have to have the 1 in front. And then next, I have negative 9x squared plus 10x squared. So that's going to be plus 1x squared, or again, just x squared. And then this guy is just going to come along for the ride. So these are Skittles and M&Ms, right? You can't put them together. I understand that they all have x's, but because they don't have, because they don't have the same exponents, those are Skittles and M&Ms, you cannot put them together. And so when we talk about adding polynomials like down here, it's the same idea. You are literally just putting your like terms together. So I see I have 4x cubed here, and I don't see any other x cubes anywhere else in this problem. So I'm just going to copy that down. So I have 4x cubed. And then I notice that I have a positive 3x squared and then a positive 13x squared. So I can add those together, and that'll be 16x squared. I don't have any plain x's in this first parenthesis, but I have a minus 6x here that I can just take along for the ride. And then lastly, this minus 2 plus 2 is just going to be plus 0. And so we would consider this written in standard form because we have the highest exponent first, followed by the next highest, followed by the next highest, and then followed by the consonant. Another way you could think about this problem, if it helps you stay organized, is to stack it. So what I mean by that is I could rewrite this first one as 4x cubed plus 3x squared. Now I don't have any x's, so I'm going to have plus 0x minus 2. And then I can fill in this parenthesis down below. So I don't have any x cubes in this second parenthesis, so I could have 0x cubed and then plus 13x squared minus 6x and then plus 2. And then you can just, since you have your like terms lined up, you can vertically add them together. So you would have 4x cubed plus 16x squared minus 6x and then plus 0. So either way, you can think of it as one long string like this, or you can stack them up vertically. You should do whatever makes the most sense for you. So I want you to pause the video, and I want you to try this next one and then unpause the video to check your answer. Okay, so I'm going to do this two different ways. So the first way, I'm just going to kind of combine like terms as I see them, which is kind of what we did in units before. So I have 5p squared and plus 2p squared. So that's going to give me 7p squared. Then I see this negative 3. There's nothing to add to that, so it's just going to go along for the ride. And then I have this negative 3p cubed. There's nothing to put with that, so it's just going to go along for the ride. So I can do it like that, except this is not written in standard form because my exponents don't go in order from the highest to the lowest. So I would need to rewrite this as negative 3p cubed plus 7p squared minus 3. And now it's written in standard form. Or if you like the method where you stack it better, let's look and see what it would look like if we stacked this. So the highest exponent that I see is this one right here. So I have negative 3p cubed. Whoops, a daisy. I have negative 3p cubed as the highest exponent, but I don't have any cube terms in this first one. So I'm going to have 0p cubed. And then I do have a p squared in this first parenthesis. So I have plus 5p squared. I don't have any p's that are just by themselves, so I'm going to put plus 0p and then minus 3. And then I can stack what I have in this second parenthesis. So I have negative 3p cubed plus 2p squared plus 0p and then plus 0. And then again, you can just add your like terms vertically here. So I have negative 3p cubed plus 7p squared and then minus 3. And so either way you tackle this problem, it's totally fine. Just make sure that you write your answer in standard form where your exponents go from the smallest to the biggest. So adding polynomials is really nothing super new. It's just combining your like terms. But when we subtract polynomials, it gets a little bit yuckier. So, and the reason why is because it's like there's this -1 that lives out here that has to be distributed to everything on the inside. So there's kind of two ways you can tackle problems like this when you're subtracting polynomials. So the first way is to stick this little -1 out in front and distribute it. So there's nothing to do with this first parenthesis, so I'm just going to copy it down. And then when I distribute a -1 in here, -1 times 4 is going to be -4. -1 times positive 2a squared is going to be -2a squared. And then from there, we could just combine like terms. So then that's not too bad. I've got 3a squared minus 2a squared, which is just going to give me a squared. And then I would have a 1 minus 4, which is going to be -3. So you can do it that way. You can also stack it, which is totally legit too. So you could have 3a squared plus 1 minus 4. Whoops, I got to stack up my like terms. Minus 2a squared and then minus the 4. And then you can just subtract that way. So you would have a squared minus 3. So either way, totally works. So go ahead and pause the video and see if you can subtract this one right here. And then unpause the video and check your answer in just a minute. Okay, so I'm going to go through this with both methods. So the first one, I can just distribute a -1 through this second parenthesis. So I'm going to copy the first parenthesis down, not changing anything. And then have negative r to the 4th, and then a -1 times this -5 here is going to make that a positive 5r cubed. And then I can just combine my like terms. So I have 4r cubed plus 5r cubed, which is 9r cubed. And then I have 3r to the 4th minus 1r to the 4th. So that'll be what? Plus 2r to the 4th. Then I need to rearrange this so that it is in standard form. The other way you could think about it is to subtract them vertically. So if I do that, I would have, let's see, 3r to the 4th plus 4r cubed. And then I have minus r to the 4th, and then I have minus a -5r cubed. So this minus a -5r cubed down here is really like plus 5r cubed. Then I can just add and subtract vertically. So either way, you should get this answer. This will be on your summative, so it's definitely a skill that you're going to need to practice. There's some Khan Academy to go over it. Let me know if you have any questions.